So it sounds like you've really been out there in the field getting a good look at what's been going on. You also went to NASA Marshall Space Center down in Huntsville, Alabama. Can you tell us more about what happened there?
After learning about cold fusion, I learned about Podkletnov's anti-gravitational experiments, and I wondered, is that a different aspect of the same phenomenon? And I was invited by Whit Brantley to NASA Marshall to witness some of the experiments that he was doing. And what I found from Whit and from Podkletnov was that they were exciting a superconductive disk with radio frequency energy. The frequency of the excitation was 3 megahertz. The diameter of the disk then was 1/3 of a meter. 3 megahertz times 1/3 of a meter produced the same velocity, 1 million meters per second. The same velocity that emerged in the cold fusion experiments had emerged in the anti-gravitational experiments. Then I really thought something profound was going on here, and I didn't know what it was. And I said, what could it be? Is it the velocity of sound? Is it the velocity of light? Or is it the velocity of something I don't even understand?
So tell us, Frank, you went to Anaheim, California to see James Patterson's cold fusion cell. You went to NASA to see the replications of the Podkletnov experiment, and in both cases you got this same velocity, 1 million meters per second. When and how did you put it all together into this classical equation that actually makes sense out of the confusing world of probability and uncertainty that dominated quantum mechanical theory for so long?
I've been wondering about this velocity for a long time. Then when I was reading What is Quantum Mechanics by the Lex Foundation, it hit me. This velocity, 1 million meters per second, is the velocity of the transitional quantum state. You see, normally quantum physics is described by the stationary quantum states. That's the orbits that the electrons occupy in the atom. And these orbits are described by a quantity of angular momentum. And this angular momentum is an integer multiple of Planck's constant. But now this new revelation has shown me the new experience had showed me the velocity of the transitional quantum state. Then I started to put things together. I realized that the vibrations, the thermal vibrations in Patterson's experiment were stimulating the heavy protons, making them vibrate in the material. And the velocity of this nuclear structure of heavy protons is the velocity of sound. And also in the anti-gravity experiments, it was stimulating things called optical phonons, and that has to do with the vibration of heavy nuclear structure. And so the external stimulation, megahertz meter external stimulation, was the velocity of sound in these structures. Then I calculated the velocity of light. What I had to do there was take a Coulomb's equation and rearrange it in the form of the spring constant, and then I could get the elastic constant and the classical radius of the electron. This is the formulation I did in my paper, and I was able to calculate the velocity of light in the electronic structure. Well, then when I set the velocity of light in the electronic structure equal to the velocity of sound in the nuclear structure, I got something very amazing. What emerged from that calculation was the energy levels of the hydrogen atom. I had produced the energy levels of the hydrogen atom from strictly a classical formulation. If this proves to be true, this will be a revolution. Now we've once again shown that Newton's laws of motion reign supreme, that the quantum world is a subset of the classical realm. And that equal sign in that formula, when I set the velocity of sound equal to the velocity of light, is very profound. It has a very profound meaning. It means that the velocity of mechanical wave equals the velocity of electrical wave. And I extended this analysis. It's much more. It means much more than that. It means that the velocity of all waves is equal during the quantum transition. And in order for all waves to be equal, the forces between the particles, the forces that cause the wave motion, has to be equal. And so what I see there is that the strength of the electromagnetic field equals the strength of the gravitomagnetic field equals the strength of the nuclear forces. And that's the condition of quantum transition, where all the forces, the strength of all the forces is equalized. It's an impedance matching state that allows the energy to flow from one state to another. Remember the problem with quantum mechanics when we have the electron orbiting and the The emitted photon does not have the same frequency as the orbiting electron. Well, this convergence of the motion constants, or equalization of the forces, actually melts the system down, and the photon emitted is remade anew.
This is fascinating stuff, Frank. As I said before, the advent of quantum mechanics has given us all of our communications technologies, from computers to cell phones. To discover new insights into a theory that has given so much to humanity already, and considering that you arrived at this derivation from studying positive results from cold fusion and anti-gravity experiments, what do you see for the future? What kinds of new technologies can people out there expect to emerge from this, shall I say, revolution in modern physics?
That's a good question. What technologies emerge from this new understanding? And what's emerging from this new understanding is an understanding of how to control each of the natural forces. Most of our technology is based around the control of the electromagnetic force. You can hold the magnet in your hand. It has a convenient range and strength. The magnet does not stick by a gravitational force. In order to make gravity work with the magnet by conventional reason, you'd have to stuff mass into the magnet. The magnet would be as heavy as the entire Earth. Then it would stick by the gravitational force. But of course, that's very impractical. And the nuclear forces, they're such a tiny range. They never leave the surface of the material, so you really can't do much with them classical. But I've shown this condition of quantum transition where the range and the strength of the natural forces converge. That doesn't mean the forces unify. They still have their distinct characteristics. The gravitational force will be gravity. It'll stick to everything. The magnetic force will only stick to metal, and the nuclear force will affect nucleons. So it isn't a complete unification. But now that we understand this process of quantum transition, we can apply it to a macroscopic body. We can vibrate a superconductor or a proton conductor and put trillions of atoms into a state of quantum transition. And strong local gravitational effects will emerge, and long-range nuclear effects will emerge. We'll be able to control all of the natural forces. That will expand the technology available to mankind by a factor of 3. Now, what I've done now is I've shown what's going on. I showed the direction forward. It's going to take a lot more to pull this together. We're going to have material scientists, electrical engineers, mechanical engineers, all design the materials to effectively harness this phenomenon. And in conclusion, I'd like to say that these experiments and this exposure of the transitional quantum state has provided a new insight to the nature of reality. And with this new insight, I'm looking for a lot of amazing things to happen.
Let's break the equation. E equals mc squared. This may be our last chance if we want man to survive. A mirror reflection, show them our world as it dies. Cut through the barrier and do what no one has dared. Let's break the equation. E equals mc squared.
Our first draw was a minor success. No control, I can but guess. We have to move now, don't know just how.